back, everybody. We lost our bell ringer, so we're just going to get started and hope that everybody comes back. So welcome back to what will be our last session of today. RPAS operator responsibilities, ensuring that staff are trained and competent, and safe planning of operations from start to finish. And to address this concept this afternoon, we are delighted to welcome back to the stage Mr. Jim Coyne. Jim, of course, as you're likely all aware, is the technical director for UAS International. And as Jim Dow already covered, I will recap. Jim holds a Bachelor of Engineering in Electronics and Communications from Queensland University of Technology in Australia, and also a Master of Science in Aerosystems Engineering from Loughborough University of Technology in the UK. Jim has been working in the RPAS world since 2005 and brings with him a depth of experience in this field. He was the Australian representative and the former co-chair of the ICAO Unmanned Aircraft Systems Study Group from 2009 until 2014, where he helped steer the development of international guidance material for RPAS. Jim retired from the Civil Aviation Safety Authority of Australia in 2014, and of course is now the Technical Director for UAS International. And I open the floor to you now, Jim.
Thank you.
No problem.
Well, hi again. Yeah, I'm getting to be a bit like Farid, as I'm up here all the time. So, but no, thanks again to ICAO for inviting me. It's great to come back to Montreal. I think this is about my women were saying before that it was her first trip to Montreal. I said I think this is my 25th. So it's really good back. It's like old home week. I've been walking around meeting all the people I've known for years. So it's great. So I do thank ICAO for inviting me here for these two conferences. So just setting the scene, we all know that the first aircraft flew on the 17th of December 1903. The Aeronautics branch of the Department of Commerce issued its first pilot license on the 6th of April 1927. The recipient was the chief of the branch, William P. McCracken Jr. Incidentally, it's interesting to note that they first offered that first license to Orville Wright, and he declined the honour because he was no longer flying. So McCracken's license was the first issued to a pilot by a civilian agency of the federal government, 24 years after the first flight. Now, the first unmanned aircraft was the Ruston Proctor, which flew on the 1st of January 1916, only 13 years after the first manned flight by the Wright brothers. The first remote pilot license in the world was issued in Australia by the Civil Aviation Safety Authority in 2002, 86 years after the first flight of an unmanned aircraft. The FAA issued their first remote pilot's license last year in 2016, 100 years after the first unmanned flight. And we heard yesterday that the FAA has now issued 61,000 licenses for these remote pilot operators. So we've now, because of that, we've now created a new class of person, an RPAS operator. And this person now has a set of responsibilities. And while they have many similarities to a manned aircraft pilot, they're also different. These responsibilities include ensuring that staff are trained and competent and that they're responsible for the safe planning and operation from start to finish. And that's our topic today. And we're now going to hear the thoughts and the ideas from our esteemed gentlemen on this panel. So I'd like you to welcome these gentlemen as they come up, and we'll hear from them. Our first speaker today will be Zia Meer, who's an Inspector Personal Licensing and Training. Zia began his professional career in 2000 with ATNS, the South African ANSP, as an air traffic controller. During this period, he began flying commercially as a regional charter pilot on Beechcraft King Airs. He also worked as a flight training instructor on Lanseria International Airport in Johannesburg. In 2014, he joined the South African Civil Aviation Authority as an ATO inspector. In June 2015, he joined the SACAA, I guess that's the South African CAA. I've got that now, it's okay. RPAS project team. He is currently a technical advisor to the South African member of the ICAO RPAS panel. Please welcome Zia.
Good afternoon, everybody. I'd planned to begin my presentation with a few icebreakers. Instead, I find myself becoming an ice cube up here. The good news is I don't have an overly long presentation, so I'll get on with it and return to my seat in order to thaw. I would like to address the topic by providing a brief overview of the South African CA mandate, our regulatory hierarchy, certification and surveillance, and the way forward. Our primary mandate is regulating the aviation industry to ensure security and safety in complying with the ICAO SARPs, taking into consideration the local context. So the question is, how do we achieve this in the context of certified RPAS operator certificate or ROC holders? At the outset, the starting point is a civil aviation regulation, of which RPAS operations are covered by Part 101. Part 101 became effective in June of 2015. We currently have 16 certified operators conducting activities ranging from cinematography in visual line of sight, to geological survey over mines, to anti-poaching operations in BVLOS over a national park conducted up to 32 kilometers away in segregated airspace. In light of the topic, the training and competency of personnel is assessed during the initial certification phase, as well as monitored during periodic ongoing surveillance of the ROC holder. This holds true for assessing the ROC holder's ability to conduct safe operations from start to finish as well. The cornerstone of this process is the operations manual, which will, amongst other things, enshrine some of the following elements. Compliance with the civil aviation regulation. At this stage, let me be clear that Part 101 is an infant regulation that will evolve over time. At its inception, as a regulator, we understood the framework of putting together a certified operation. What we did not know is the what, where, and how of the actual operations in the RPAS context. Hence, this required a partnership and cooperation with the various ROC holders, in which they would follow an operation-centric approach, where the operator comprehensively defines the type and scope of the operations to be conducted. The operator would then define the training and competencies required to achieve a safe and successful outcome to these objectives. Competencies over and beyond the regulatory competencies required by the regulation. The regulation in its current form prescribes what is required to obtain an RPAS pilot license under VLOS conditions. Since it was a first iteration, it did not make the distinction between RPAS operations and small UAS operations, rather approaching all form of unmanned operations with an umbrella approach. Considering that the BVLOS operations that were certified to ROC holders is conducted by small UAS aircraft within relatively small areas in segregated airspace, it was left up to the operators to propose an operation-specific training program to the regulator, which would be assessed using available best practice and the regulator's experience. Thus far, this process leads to BVLOS approval for the specific operation, rather than a blanket BVLOS endorsement. Once approved, this is checked against training records and ongoing proficiency checks. which are designed by the operator and approved by the regulator in light of the type and scope of the operations conducted. Proficiency checks will at a minimum cover emergencies, systems failures including loss of power to the RPS, structural damage, and low battery conditions. Administrative competencies are also required to be assessed, such as mission preparation, flight folio management, including fuel and charging records, power reserves, incident, accident, and hazard reporting. Our experience thus far has been that operators are highly experienced in the operation of their equipment, but have little aviation experience, a sentiment that has been expressed at some of the presentations here today. All RPAS pilots are required to obtain a restricted radio telephony certificate as per the South African Civil Aviation regulations. In light of this limited aviation experience, generally found amongst operators, ongoing training and assessment of airspace knowledge and radio telephony competencies is necessary. In terms of the safe planning of operations from start to finish, the operation manual lays out a program of induction training for all personnel involved in the operation, deployment, handling, security, transportation, and storage of the RPAS, which is documented by the operator and verified upon surveillance audits by the regulator. In light of security fears, all personnel involved in the deployment, storage, and handling of RPAS required to undergo background checks. They must also have completed an approved aviation security training course. The operator will have to comply with an approved safety management system, which includes, amongst other things, a safety policy, as well as processes for hazard identification and risk mitigation, gap analysis, etc. South Africa, being a member of the ICAO RPAS panel as well as JARIS, relies on these as sources of best practice. As such, we have adopted the Specific Operation Risk Assessment Approach, or SORA, which in terms of specific operations will also include, in advance of the operation, flight planning and preparation, dealing with the scope and feasibility of the operation, site location assessment, including airspaces, obstacles, etc., risk management, communication procedures, notifications to affected parties and air traffic service units, and weather. In terms of on-site procedures and pre-flight checks, a site visual survey is conducted, selection of the operating area, a crew briefing, cordoning off procedures where applicable, an assessment of the communication range and capability requirements, real-time weather observations, refueling or recharging procedures, loading of operational equipment, preparation and assembly of the RPA on site, pre-flight and post-flight checks. Flight procedures to include planning for the start, takeoff, in-flight phase, landing, and shutdown of the RPA. Part of the operations planning should include emergency procedures unique to the RPA being operated, or I should rather say specific to the RPA being operated, fire risk and preventative measures, accident considerations and emergency response plan, loss of control link, and the operation of the RPA under normal, abnormal, and emergency procedures. In the case of initial certification, one or more demonstrations of the operator's ability to achieve a safe and successful operation are conducted. In terms of some of the challenges we face and the way forward, this involves the recruitment and training of suitable technical personnel, review and amend and streamline internal processes, embark on expanding the scope of Part 101 to cover other topics, including the clear distinction between RPAS as per the ICAO definition and small UAS, streamline and strengthen the rules of engagement with stakeholders and partners, which is of vital importance because it's our primary source of data in this new exciting field. And keep in step with global initiatives on RPAS development through the participation in forums such as this, our participation in the ICAO RPAS panel, and at JARIS. On behalf of the South African Civil Aviation Authority, I would like to thank ICAO for granting us this opportunity to be represented here today. Thank you.
Thanks, Ian. It was a good presentation. I see you're doing some BVLOS operations in South Africa, which is interesting. Yeah, I'd like to talk to you about that later. It's very good. Okay, our next speaker is Robert Hannaford, who's the Technical Director and Co-founder of UAV and Drone Solutions. Robert was born in Johannesburg, South Africa in 1966, just a kid. He qualified as a telecommunications engineer in 1986 and then went on to study data comms at WITS Technicon in 1990, embedded microcontroller development in 1994, and Microsoft Systems Engineering in 2000. After he founded a large cellular repair organization in South Africa, he then went full-time mobile application development and founded a company called MyDigitalEarth.com. Robert is proficient in many programming languages and multiple IDEs. His current interests are in unmanned aircraft vehicle technologies, and recent, together with partner Otto Werdmuller and George Sager, has founded UAV and Drone Solutions Proprietary Limited, specializing in unmanned airborne solutions and technologies. Robert is currently a student at UVU University and has completed multiple courses through UUV, including a flight training program, and is currently enrolled in a master's degree. Please welcome Robert to the stand.
Hi, ladies and gentlemen. Thank you very much for affording us the opportunity to speak today. I'm going to get right into it and start with where it all began and a little bit of history on UDS and why it was formed. It was really formed to take advantage of the progress in the latest commercial unmanned technologies that were currently available. And the areas of interest and the areas that we focus on are predominantly conservation, surveillance, 3D mapping, and a host of engineering services. Some of the company's core competencies are design, fabrication, and systems integration, as well as light engineering, which includes a lot of composite technologies as well, embedded microprocessor development, some mobile application development, and flight and training on RPAS systems. Our ROC was issued on the 9th of October 2015. We'd been flying for probably about 2.5 years prior to this, and we were effectively grounded during some operations in the Kruger National Park, performing counter rhino poaching flights, and we were asked to follow the regulations and to follow the process and to get in line with what civil aviation required from us, and that was to go through this process of becoming approved. We were the first approved license in South Africa, and the approvals were issued for Class 1A up to 1.5 kilos, and Class 4A BVLOS, although it says less than 150 kilograms there, we only operate RPAS or SUAS vehicles of under 7 kilos. What was fairly unique about this ROC was that we were the only guys to be issued an ROC with BVLOS and night operation capabilities, and this was predominantly due to the work that we were doing in national parks to prevent wildlife crime and to really offer support to anti-poaching units on the ground. We basically became their eyes at night. Since the ROC was issued, we've logged 13,200 hours. We've had one major accident, which was reported to CIA, which resulted in the loss of an aircraft, and we've had 56 minor incidents and accidents reported. On that slide, you can just see there's some restrictions and limitations, and then there's some UDS-specific approvals and limitations. And the ones that were really interesting for us, or the ones that we required, were obviously the use of a public road as a place to land, as a place to take off and recover the UAV. This obviously goes with permission from the relevant and local authorities. And the other was to perform night operations and to perform operations above 400-foot AGL. Our current staff complement, we have 25 pilots, 23 of them are dual-rated, fixed-wing and multi-rotor qualified, and they're 2 single-rated multi-rotor pilots. We have 10 sensor operators, 1 accountable manager, 1 responsible person for aircraft, 1 responsible person for flight operations, a safety and security manager, a quality manager, and 5 administration and compliance personnel. Our current fleet consists of, and these are CIA registered vehicles or registered craft, 9 fixed-wing aircraft, 5 multi-rotors, and 12 pending LOAs at the moment. Staff training, all of our pilots hold current CIA certified RPL licenses. Most of our pilots have been through controlled airspace certification, and our pilots all receive aircraft-specific training. And the aircraft-specific training, because we do a lot of our own building and manufacture of our own aircraft, goes way beyond just learning how to put the aircraft together. It requires that the pilot actually spends time in a workshop environment, learning all the intricacies of these aircraft. We generally look for technical type people to operate RPASs. We have not, although we've employed some manned pilots, and I'm probably going to take it on the chin for saying this, they've turned out to be some of our not really competent pilots when it comes to operating RPASs. We've generally found that taking a technical person and training it, or putting a technical person through our internal training program, has resulted in somebody with a different set of understanding for our specific types of operation. We also had to develop an internal BVLOS certification program and a checkout program, and it's purely company specific, although it's something that the CIA have had a look at and are fairly happy with our approach to doing BVLOS training. It takes us on average 6 to 9 months to create this individual and turn him into a competent BVLOS pilot that can be left to run a mission on his own, or a minimum of at least 200 hours. And those 200 hours are spent in real life situation where he operates with a senior pilot under his command at all times. We're very, very fortunate in the sense that there are a couple of our customers that have very large facilities, sort of 7 by 8 kilometers. We've got a 56-kilometer square area that we use for training, and these are live operations while training is taking place. So we're fairly fortunate in that we can train and retrain until we get it right with pilots, or eventually disband some of the guys that can't get there. There's continuous refresher training that is done all the time, and this includes our own UDS induction program. A lot of task-related induction is done annually and biannually. RPL-related induction, so we revisit all the subjects just as they were in PPL, because the RPL license that we do is a subset of PPL data. Safety and quality induction, and all the emergency response induction. Our sensor operators hold an internal company payload certification, and we also require that the sensor operator go through ground school and get the RPL ground school training as well. Our teams normally consist of a sensor operator and a pilot, and we find that having the sensor operator have the same knowledge, not necessarily the flying skill, but have the ability to read instruments and understand what it is that is going on is of huge benefit to a team when they're operating together. The sensor operators also, as I said, receive very specific payload training, depending on whether we're flying LiDAR, whether we're flying thermal images, whether we're flying multispectral cameras, they're trained accordingly. The safety and security manager that we have is we had decided to employ a commercial helicopter pilot that had specialized in night operations. He flies for a vehicle tracking company. He's active and has many, many hours, and he's proven to be a great asset in terms of transference of knowledge to a lot of the SUAS pilots. He's also done safety management system course that CIA approved, and he's also familiar with our own internal risk assessment and analysis tool that we've developed, and I'll come on to that a little bit later on. We've also have a quality manager who has passed all the quality assurance courses that CIA have asked us to put in place. Our current operations, 90% of our operations are night-based operations, predominantly conservation areas, industrial sites, container depots, and rail yards and infrastructure are the areas that we currently find ourselves concentrating on. Our current operation statistics, we fly on average 200 hours a month on multi-rotors, around 400 hours a month on fixed wing, and we are operational for around about 20 days on average every month. We have 6 teams that currently operate, and the team consists of a sensor operator and a pilot, and they would normally fly around about 6 hours a night. Now, these are generally split up, if it's a fixed-wing operation, into a 2-hour session with normally a 30-minute interval between the 2-hour sessions. Typical operation procedures begin with an off-site survey, where we do a lot of remote research online based on what on the client telling us where it is that he'd like to perform the operation. If a KMU application is required, it would be completed and sent to ATNS, and it normally consists of GPS coordinates for the proposed area of operation, the various operational VHF frequencies for that area, the tail number of the aircraft, of the registered aircraft that's due to be used, and the date and times proposed for those operations. On-site preparation, and this is very high level, starts with a cordoning off of the flight area. All relevant CIA required paperwork is completed, and at the moment we're in the process, we still run a dual system where we're running both paper and we're running an electronic flight folio system. We're busy ironing out bugs with the flight folio system from a digital signature point of view, because the signature is required on a lot of the CIA paperwork. We then go through a site briefing with all relevant stakeholders and parties, and we set up the GCS and we set up the RPAS. The mission planning and the uploading of the mission is then completed. A pre-flight inspection is performed. Mandatory radio calls are performed throughout the mission. Mandatory radio call is performed before the mission, announcing the RPAS's tail number and ID and the proposed mission planned. Launch execution of the mission and recovery, and radio calls every 15 minutes during those operations, as stipulated in our particular ROC by CAA. Post-flight inspection of the RPAS once recovered, mandatory radio calls with details complete, and then the completion of the flight log. Ongoing development, we've just recently passed or had a BARS referenced audit done by Litson and Associates. This was required because of the nature of the work requested by some very big corporate organizations. We came through the BARS referenced audit successfully with a handful of findings that have to be resolved. We're working on a health condition monitoring and predictive maintenance tool for UAVs, and we've released a mobile application for accident and incident management. It's a tool for both Android and iOS called Red List. It's not available to the public. It's available to a closed user group for our own internal use. And we're also developing an online UDS training and evaluation tool to allow our pilots, very much in the same way that a PPL pilot would go in and do it and write tests online. We're doing the same kind of thing to continually evaluate our pilots' knowledge base. There's an ongoing development path for our own internal BVLOS flight training program, and the same with safety and operations training program. Just in closing, the journey that we faced when we first started this operation, and I don't come from an aviation background, I'm a technical guy, and I was very, very interested in the RPAS or the small SUAS space. When we originally started this, had we known what was going to happen and the path that we were going to go down and the kind of compliance that we were going to step through, we often question whether or not we would have gone down this road. Having walked through it now and having appreciated what happens in civil aviation and what happens with manned aircraft, from my point of view, I only believe that for BVLOS type operations, that things should be, and I don't want to say more stringent, but every single possible means of making BVLOS operations safe should be applied to these operations. And I'd just like to say thank you very much for inviting us to ICAO.
Thanks, Robert. That's a really good real-world application of showing how you do your planning for your safe operations. Really good, thank you. Our next speaker is a long-time friend of mine, Mike Gadd. Mike has over 35 years technical and management experience within the aviation industry and as a regulator in the UK CAA and the European Aviation Safety Agency, EASA. This includes the initial design, certification and continued airworthiness of a wide range of aircraft types, organisation approval assessment and oversight, and the development of regulations, requirements and guidance material. He has held subject matter expert and technical management roles and currently leads the CAA teams developing policy, regulatory material and guidance and the day-to-day assessment approvals of operator permissions and UAS National Qualified Entity approvals. Mike participates in and supports a number of regulation and requirements development forums and was elected as the Vice Chairman of ICAO's RPAS panel when it was first established in 2014 following the end of the UAS study group. And he was elected as the Chairman in December in 2015. Please welcome Mike to this podium.
Thank you, Jim, and good afternoon, ladies and gentlemen. Much of my presentation is quite similar to what many have already presented today, so I will do my best to cut out what is a repeat and just focus on some of those aspects that are much more focused on the training and competency aspects that today is focused on. The full presentation will be available, so the detail can be referred to later. So in terms of the UK position, I think first just to cover some of our very key principles. And that is all of our focus is to protect the general public, sometimes referred to as third parties. But it's a core principle that we look at for all the material that is submitted. As we've heard several times already, we agree that these are considered to be aircraft, albeit they are an evolution within the aviation domain. We also agree that they are piloted. The equivalence topic comes up quite frequently, and we try to be clear that equivalence to manned aviation is an interesting topic because it does not mean it is identical. There are many sectors of unmanned aircraft and RPAS where there is no manned equivalent. So we are looking for the best match we can to give us a baseline. We also uphold the principle that there is no automatic right to access the airspace. Unmanned aircraft systems, like manned aircraft systems, have to meet the rules, the regulations, and demonstrate that they can fit into that system. So for us, we embed that as two core statements. We look at the vehicle, and we're trying to understand that it is safe to fly. And we look at the operator to see how they can fly them safely. What that means for us, we break things down into two very simple concepts. These things are either visual line of sight, where the core responsibility is for the pilot to discharge their obligations for safety because they can see what they are doing, they can see what is happening, they can use their training, their competence, their common sense to discharge that responsibility. And beyond visual line of sight, where they cannot use their eyes and they have to rely on technology and all of the variability and failures that can go with that, and therefore have methods, processes, and procedures to mitigate failures of that technology. In terms of our legislative systems, we have two layers. At the top end, we have our primary legislation covered by the Civil Aviation Act. And that empowers the Civil Aviation Authority to work within our secondary legislation, which is documented in the Air Navigation Order. The one point I would make on this is the Air Navigation Order allows us to make and permit almost anything to fly. There is nothing prohibited specifically in it. I quite often hear people comment that BV loss is banned in the UK. No, it's not. It's already capable within the Air Navigation Order. We introduced our rules for unmanned aircraft in 2006. We've been using them for over a decade. The issue is for operators to demonstrate that they can do that safely enough. And I'll come on to the way we do that for the small UAS in a moment. If we do get into certification, we have long-established airworthiness requirements that enable us to do that. And we support all of that, whether it is certification or whether it is, should we say, what we're talking about here as small or other categories of operation. They're all covered off and detailed in information procedures. And some specific guidance that I'll touch on a little bit later. The core points, and I'm not going to go into detail, as I say, you can read these at leisure. If we are talking about unmanned aircraft, we always refer to the article of endangerment, the core principle of not creating chaos to other airspace users, or even those on the ground. What we have done for small UAS, and by that we mean less than 20 kilos, is made a very, very simple subset of those requirements, those regulations, that apply if you can meet the terms that these say. And that is Articles 94 and Articles 95. I won't leave them up there, you can read them at leisure. But these two articles define the minimum set for small UAS. We have some guidance for those that are considered to be leisure users. The drone code, as we call it, very simple leaflet that identifies the core basics that are on those Articles 94 and 95. A web presence also. This is part of that thing we've spoken about over the last few days on education, informing that sector of the community that is not known within aviation, but would wish to make use of the benefits that this technology is bringing to us. When that community would wish to use these machines for commercial benefit, a little bit different view. they do need a permission from us. The process of that permission is documented in this guidance document. And the core things I would just draw out here is what we're looking for in order to be able to issue an operating permission. And that is for operators to demonstrate that they can do this safely. And I don't mean absolute safety, I mean safe enough. Because that is one of the core principles of proportionality. That means for us that we take an operations-centric approach. And we're looking at how the operator can use his equipment, his procedures, his process, and the competency of his team to meet that safety obligation. And how they're going to do that is what we expect them to demonstrate in the documentation, in their handbook that they provide to us, as a basis for us to say we are satisfied that it looks like they can operate safely. So, for commercial operators, we have a little bit of a description of when they must have a permission. Okay, I'll leave you to read this at leisure. But what we do is we break those permissions into two main categories. We have a standard permission, and by this we mean that it's a commercial operation, but it's completely within the constraints and restrictions of the two articles I mentioned. So it's actually very similar to what anybody can do for leisure use. The conditions is visual line of sight, and they have limitations on how close they can get to persons, vehicles, vessels, and structures. The only difference here, as a commercial entity, we're looking to see how they risk manage themselves as a business. Non-standard permissions is the area where we get into everything else, where people want to get closer to buildings and people, wish to go further than the visual line of sight rules, wish to do more demanding, more challenging aspects. It's where we would deal with a BV loss type of operation, should that be requested. And it's the one where we start to get into evidence of competency for the pilots, as well as, the bottom line there, the justification through a safety case process. I won't read this, it's a little small, but what this does is, much as you heard from my colleagues here, a series of aspects that we're looking to be demonstrated for competency. I'm going to read from my notes, because even for me, the text on the screen is just a little small. We have two aspects for the competency demonstration. We're looking for the theoretical knowledge, which, again, has been discussed by many today. And this is about understanding airmanship, the rules of the air, the expectation of others, how they're going to interface with all of those other people that use the airspace. And we're looking to establish that that is backed up by some experience, some demonstration of that, whatever that minimum needs to be. And then we cover what we're looking for in terms of practicalities. A demonstration that they understand their machinery, the features it has, the capabilities it offers, and importantly, what happens when it goes wrong. Do you understand how your machine will behave if it has no GPS or your command and control link goes down? How are you going to recognize it and manage it? So the practical assessment looks at, can you use the machinery manually, some of the automation modes it might have, and deal with it when they fail to work. And we look at this in two ways. So we accept the demonstration of competency, either because they use a facility we have set up called a National Qualified Entity. This is a CAA-approved organization, and they have a permission, they have an approval with privileges to assess remote pilots and make a recommendation to us that they have demonstrated sufficient theoretical knowledge by an examination process, and that they have shown appropriate degrees of competency to operate their machine in accordance with their own operating handbook and principles and procedures. That is important to us because that shows us that the pilot has used his own documentation. His own documentation means he understands what he was writing and why, and that the risk assessment in there is understood. It's his risk assessment. He has learnt the process of understanding threat and risk and mitigation. It's not something he's just downloaded as a template. It has to be his work. So these NQEs, we have two categories, a full category and a restricted category. The difference is quite simple. A restricted category can only do the practical flight assessments, whereas a full category NQE can do the examination and recommendations for the totality. Now, these have been running for quite some time now, and in terms of what they look like, what we're looking for, that is all within our documentation in reference in the CAP 722. But because this has been running for a while, we've also had some feedback, both from the NQEs themselves and from the students that have gone through their training. And that enabled us in the middle of this year, in May, to issue an information notice to clarify some of the understanding and our aspirations and intent. That's our first step in taking lessons learned and reworking the system. And as we go through the NQE process, their approval, which is valid for 1 year, when they apply for renewal, we will be looking at how they have responded to that feedback and those updates. So we are closing the loop and we are updating our approach to these things as we get knowledge of the operation and knowledge of the product that it is producing as pilots. So with that, I'll say thank you for your attention.
Thank you, Mike. That was great. I particularly liked your reference to the education for the public. I think that's a very important issue, and maybe it should be a topic for future symposia. I think it's a very important message to get out to the public of what's happening in the RPAS world. So our next speaker is Nick Rogers, who's the co-founder and chief regulatory and training officer at Sky Futures. Nick is one of the co-founders. He brings with him a wider aviation knowledge and strength in depth to the team at Sky Futures. He is a qualified civilian airline captain, currently rated on Airbus A320 series, having previously flown the Boeing 747. Since the business founded in 2009, Nick has been instrumental in gaining permissions to operate unmanned aircraft in over 24 countries. Nick's in-depth aviation understanding and ability to look forward at the emerging UAS landscape has earned him significant respect from aviation authorities globally, who regularly call on him for industry advice. Nick is an internationally recognized thought leader for unmanned systems and future airspace development across manned and unmanned aviation. Please put your hands together and welcome Nick to the podium.
It's always awkward listening to your own bio that somebody else wrote, so thank you very much, Jim. To ICAO, distinguished guests, it's a real honour to be here representing not just the operator perspective, but I suppose also industry as well. And really, I wanted to come here today. You've obviously heard a lot about the regulatory insight that that these aviation authorities are putting towards the emerging unmanned landscape, but also really to try and put the best foot forward for the industry as well. So it's a real honour to be here. Thank you very much. So I'll just start with a little bit of background about Sky Futures. Clearly we're not one of the big names that have been around the bazaars over the last few days, but really just to set the scene, to try and explain, how we've been using this technology to develop out our business over the last 7 or 8 years. So if I wind back to 2009, we're very much a startup. It was myself and 2 Army captains who had deep insight into the military applications, specifically with actionable data and the change process that they could monitor using unmanned systems. And we thought that we could apply that to the commercial space. But if I'm being honest, we didn't really know how we could apply that. So very much we've gone from startup to a real business with real clients, with real investors in both venture capital, but also Bristow Helicopters and Mitsui, who's our latest investor we announced 3 weeks ago. So the business has grown really with the technology, and but if I wind back to 2009, we really didn't know how this technology was going to impact the commercial space. So as I stand here now, we're very much active both as an operator but also as an enabler to the industry through a number of different I suppose market verticals, but specifically we concentrate on vertical infrastructure inspections, be they bridges, utilities, wind turbines, renewable energy type infrastructures, telecoms, but also oil and gas facilities, both onshore and offshore, and larger industrial facilities. So when I wind back to 2009, what was the value in this amazing aerial perspective? We all knew we could take pretty pictures, but where was the value? Where did it lie? So I couldn't get an aircraft directly into this slide, but I've got something with wings on in the sense of the Mercedes Gullwing. But really, the opportunity for us as a business was to use this as a revolutionary technology for asset management, so across the various different structures. So what I want to spend just a little bit of time today is talking about really is kind of the way in which our business is being driven by clients and customers, and actually how really we should be looking to put the regulation around that to try and help enable the technology, and perhaps not the other way around. So one of the best stats is the GDP figure. I don't know how many people knew that 3.4% of global GDP, certainly from a stat in 2013, is spent fixing stuff. Corrosion is obviously all present with the various weathers we have around wherever we are on the globe, but ultimately that really was the unique value proposition that drones gave us as a business to be able to diversify into the sorts of things that we do today. And there are some really good parallels here with a time-based inspection process that health and safety executives might say in the oil and gas industry, you must inspect your oil and gas rig once a year. Whereas actually the industry now, through this emerging technology, is developing into a risk-based inspection process, which is obviously very akin to the sorts of things we're trying to achieve in the regulatory world when it comes to the aviation space. So I see a lot of parallels in terms of the technology. So, if in 2009 it took a 4-person team hanging off ropes for 8 weeks to baseline that oil and gas structure, they would then spend another 6 weeks producing a Excel spreadsheet in the form of a report, which was only available to one stakeholder, which would ultimately have cost the business $1 million to produce. Okay, we thought that we needed to use that to change the status quo, and that drones presented a fantastic opportunity to be able to do that. So I now stand here saying we're obviously safer, it's obviously 8 times faster, it's certainly a hell of a lot cheaper than it used to be, but importantly it's better data. And so when we talk about the regulation fit, what is it that people want out of the back end? So I'm just going to go back a little bit about what that means in terms of a clear depiction in terms of what is this data that we're gathering and how we're doing it, and how can drones really change this, and what's the framework that's starting to emerge around it. So obviously in the scenario I just gave, a hell of a lot of data gathering followed by a pretty good amount of data sorting. Then obviously there's data analysis action, and then you'd finally get to the action point at the end of that process. So by about 2011 we were operational with blue chip clients around the world delivering drone inspections. So we get 2 gig of data, and then what problems, we thought this was going to be the golden bullet. Surely this is a technology that's going to change things. Well, we found that actually it changed the problem into 2 different ways, because the data gathering was obviously quicker, but actually then, instead of that person being hanging off the rope, you've then got them burning their Mach 1 eyeball out on a computer screen, looking at a 2D thing, trying to make sense of a 3D structure. So the data analysis was taking a hell of a lot longer, and then we got to the action point. So we swapped out some problems for some new problems. So as I stand here today, then obviously the real benefit in the drones is starting to come forwards, and that's through significant technology advances that hopefully our company is leading through, obviously, the unique characteristics of the drone, which is obviously data and telemetry, but then followed by the ability to be able to situate this data and telemetry into the cloud, but also the automatic data analysis that's starting to sit behind it. And this is where you're probably thinking, why is Nick standing here talking about data capture rather than perhaps the regulatory environment? But actually, it really is indicating where, I suppose, the client is driving the industry towards, and where I believe that regulation needs to start moving towards to be able to make this leap into the automation space. Because actually, if you take your oil and gas rig, there's no reason why a drone cannot be 24 hours a day going around that structure, collecting information, working out towards that risk-based approach, so that you can actually start to predict failure on that particular infrastructure. The same would go for rail infrastructure, utilities infrastructure, and that's the unique characteristics of the drone, which are delivering something that's completely new. So really, there's this move towards automation, which is where perhaps we need to understand why, we need to understand where the technology is going and driving towards, such that we can help, through the regulation, we can help that technology advancement along the road. So really, RPAS operators, pilots, whatever you want to call them, this is a new type of aviator. These are people who are driven by the data that the drone can output, rather than perhaps necessarily the process of gathering the data in the first place. So really, I believe that national aviation authorities have a fantastic opportunity to work with industry bodies to facilitate this growth of this new era of what we would, I suppose, call industrial aviation. So as a business, we have to provide a number of things to enable that process. One is RPAS operator training, or remote pilot training, through our full NQE status that we have in the UK. And we also have a similar facility out in the States, which is run by TEEX, or an extension of the Texas A&M University there, which has like-for-like scenario-based training opportunities where we can deliver fit-for-purpose real-life training. So the training is absolutely critical to what we can do to support the technology, but also to manage the regulatory environments in those 24 countries that we've operated in. Equally, we still provide an inspection service because that's important. We have to keep learning the lessons, but increasingly we are putting software to harness the unique characteristics of the drone, which is obviously telemetry and data that harmonise together. So within the suite of softwares that Sky Futures is developing, it's proprietary, developed in-house. We have 2 softwares. One is called Expanse Flight Deck, which manages the telemetry side, and the other one is called Expanse Inspection, which is managing the data for our clients, all securely held in the cloud, leveraging the abilities that cloud technology can bring to us. Equally, we are also spending a lot of time with some of our larger PLC type clients, big blue chips, who want a drone strategy. Some of them come to us and say, just do the operation, gather the data and give me the results. But others might say, technology is really important to our roadmap, therefore we want a drone strategy, which means that potentially thousands of people within our organizations, like engineers out in the field, will be collecting this data, and then they'll use our software to be able to develop out the data understanding across the various infrastructures that they may wish. So the consultancy piece is starting to get quite important as well, because again, this new type of operator, they're coming into an environment which is completely alien to them, and I think Rob probably alluded to that earlier. And it is quite complex to navigate, so we're helping quite a lot with that as well. So in terms of combining the operations, engineering, technology experience, things like Spectrum, certainly in the UK, I feel like there's been some really good leaps forward, specifically in the last 12 months, where you're starting to see the UK CAA work pretty closely with Ofcom, but also industry bodies as well. And I've been very much trying to spearhead industry bodies to start talking to the civil aviation authorities to make sure that there is an understanding across there. So I believe that there is in terms of the co-cooperation across the various regulatory bodies, then that's probably something to take away as well from today, and certainly something we've learned that's really valuable to us as industry players. Just to go back to training as well, I mean, a lot of really good stuff was said today, and we very much baseline those core competencies, the pilot training elements, against exactly what you heard today. The one thing I would try to reinforce is that scenario-based training is absolutely critical, and certainly for an ab initio new aviator coming into the space, who you need to onboard quickly, but obviously efficiently, because otherwise you're not going to get the time with them. I mean, these engineers will give up valuable time to be able to come and learn to do this, so you need to make that process efficient. So just like back in 2004 when I started my formal civilian pilot training, that saw me sitting in the right-hand seat of an Airbus 320 with 150 hours in the logbook, it's the same, really, the same approach, which is coming towards the ab initio training that we're giving to our people. So just looking at that schematic, this is not, obviously it's not one size fits all, but on the left you've got a training program that we use using the DJI Inspire 1 system, delivering to typically emergency services, and one of our most fun clients would be Mid and West Wales Fire and Rescue Service, who from a standing start with no drone knowledge whatsoever, within the last 12 months now have 24 remote pilots, night and day capable through the training program that we offer. It's all scenario based, it's all fit for purpose, and it onboards them as quickly as we can, in the real environment, so that they're capable of being able to respond as soon as they come out of training. Clearly it doesn't stop there. They're all coming back over the next 12-month cycle for recurrent training, which is something that they ask for. This is not something as an NQE I can dictate that they need to do, but it's something that clients are coming to ask for. So that's, for me, is really, really positive. But the scenario-based element, not doing flying training in fresh air, is so critical, and you must be able to deliver that, I think, to become, a proper training organisation, certainly in the RPA world. So just a little bit on the flight deck software, which is something, one of my continual frustrations as an airline pilot is that by the time I get to the flight deck, quite often I've interfaced with, certainly in my current role, I've interfaced with 6 stovepipe pieces of software to get the information I need to make the flight safely. So with Flight Deck, it was obviously an opportunity, a blank sheet of paper, to be able to embed all of the processes that we've heard lots about over the last few days into one piece of software, which is securely held in the cloud. Again, leveraging some of the opportunities through the telemetry as well. So safety management systems, pilot logbooks, risk assessment, method statements, any of the operator approvals that you need, all of your operations manual, they all sit in one central place and against the same sort of workflow, same for the tech logs for the aircraft. So everything is centrally held, which is really important. And certainly as the compliance piece comes into people's mind, and I'm thinking of our emergency services clients, but also the large blue chips, then obviously this piece of software is quite interesting to them, because actually with the ability with things like flight playback, which is essentially your FOQA or your flight deck monitoring system, you're able to play back to them in real time exactly what happened on their flight from the derived telemetry that you've downloaded subsequent to the flight with the aircraft. So we're starting to see the opportunity for that sort of training coming in as well. One of the potential opportunities is some virtual BV loss in 2018. If you've got any questions, come and speak to me afterwards. But there's Mike, I might be knocking on your door next year. So really, I just want to summarise with some key development themes. I realise that my talk is perhaps slightly different to the pure regulatory stuff, but I think it's important to show that absolutely we have to support the technology through regulation rather than the technology being stifled, I suppose, by regulation at the back end. But, you know, there's some really, really good stuff, certainly, that I've heard over the last few days, and I think, you know, although there's a ways to go, we are making some progress from perhaps where we were a few years ago. Risk-based approach, I think, is one key element that we need to keep pursuing. I think that if regulatory insight can help towards that automation piece, I think that will be really instructive and actually exactly what the technology will need to be as successful as it can be. Scenario-based fit-for-purpose training is clear from all of our discussions today. EBT principles are very prominent, I think, through both the manned and the unmanned aviation spheres, and they do show some equivalency. Control mechanisms, we haven't talked too much about security, and I guess it's not really for this conference, but obviously a data security element is coming into my daily conversations with clients, and it's something that we ought to have, you know, certainly one ear out for, to make sure that we can manage the concerns, not just for clients, but also the third parties as well. Industry body collaboration through Oil and Gas UK. We've done some great stuff as an industry partner, but in cahoots with other industry partners, we've managed to deal through the Oil and Gas UK body to be able to deliver some stuff to the regulatory stuff in terms of industry regulation, which then supports the aviation regulation that's out there. And finally, airspace obviously all airspace needs to be as safe as possible, both to the user and the third party, but equally the whole notion of interoperability, I think, is massively important. You know, we must try to, although there are segregated BVLOS flights going on at the moment, we must try to work towards the goal where both BVLOS, HAPS, even satellite, the whole airspace is looked at as a single dimension, and that we can be interoperable between all of these types of technologies. And I think that should be a final goal for all of us as regulators and industry players, although it may take some time to get there. Thank you very much.
Again, that was great. A good real-world application of training and planning by an operator that's working. We've got a few questions from the audience. I'll go through those, then I've got a few for the panel. We've got about 10 minutes. So this one's directed directly at Robert. So Robert, since your sensor operators do have the minimum RPL training, do they often move from sensor operators to pilots? And if they do or intend to do you find the set of competencies for pilots and sensor operators to be significantly different? Robert.
So to answer that question, some of the sensor operators certainly aspire to becoming pilots, and generally we start a sensor operator. We normally start guys out that have come to us for an interview as a sensor operator before they migrate to pilots. But the RPL training generally starts to sift out the guys. If they're going to stay sensor operators for the rest of their time, well, so be it. But the RPL training that they go through is something that we feel is very, very necessary for the sensor operator, because he plays a significant part in any of our missions that are flown. And although he is monitoring the sensor, and very often it's a video image with a heads-up display, with an on-screen display overlay of data, it acts as a second pair of eyes for the pilot. So it's not that he gets heavily involved in the piloting and the monitoring of vitals, but he certainly adds to an extra element of safety during that operation. Does that answer the question?
Yep, that's good. And the next one I've got is for Mike. We would like to know from which criteria the UK CAA established the 22 kilogram limit for small UAVs.
I think I've had this question at least once a week for several years. The reality is it's a little bit of history. There was no hard and fast rule. We looked back at a range of aspects that were the best we could look for in terms of UAVs, and that related to the model aircraft world. And so it was a purely simple, very early equivalence argument that we understood the technology and the capabilities of model aircraft and what they could do, and there was some similarities we could use as a basis to read across.
When I chaired the UAS study group many years ago, we had the Brits had a 20 kilogram rule and the French had a 25 kilogram rule, and I was going to try and make it 22.5 to annoy them both. Equally. Okay, I've got a couple of questions myself for the other guys, for Nick. As you introduce any new tasks that your remote pilot hasn't actually performed before, how do you go about training them and then ensure that they are competent in that task?
Okay, so to answer your question, I think the important thing is that if you've got, I mean, a lot of it's driven by our client basis and the sorts of things that they do. So we're very lucky with our training academies that we have representative structures on that secure site. So I think, we try and concentrate to our strengths, but we also have an engineering team up in Aberdeen who cover off all of the vertical, all of the market verticals that you saw in that photo on the second slide. So to answer your question, we obviously gather industry knowledge and understanding. We try and pass that on, and then obviously things like flight routines and flight profiles around the various structures are embedded during the training process. So it's very much specific to the infrastructure. So that scenario-based training is backed up by reinforcing what we've learned. But I suppose probably the best example recently, we got involved with some solar work, solar energy, and that was an infrastructure that we hadn't really, we didn't have much experience with. But I suppose fortunately solar panels are quite flat and fairly uniform in their shape. So I suppose the flight planning elements of that particular task perhaps weren't so onerous. When it comes to the complexities of an oil and gas rig, that's different, which is where we lean on our engineers to give us the insight to be able to develop the remote pilot training, to be able to split up. It might be a flare inspection is different to a riser inspection, is different to a derrick inspection, is different to a satellite communications inspection. So if that answers your question.
Yeah. Thanks for that. And Zia, so you've got a number of operators over there that are doing BVLOS operations. Now, how do you, as a regulator, satisfy yourself that the operators are planning their operations safely? What evidence do you gather, and how do you go about ensuring yourself as a regulator?
Okay, thank you for the question. Each operation needs to have its SORA completed. There's also a field operations manual that needs to be drawn up for each operation. As I mentioned in my presentation, there's a pre-flight planning phase, there's a on-site planning phase, a flight planning phase, an emergency response phase. This needs to be documented, and that's overseen during ongoing surveillance audits.
Thanks for that. And I guess one more aimed at all of you. There's been a bit of talk about risk assessments, also job safety assessments for each individual jobs. I guess we're fortunate here in this panel that we've got 2 regulators and 2 operators, so they're looking at it from a different perspective. So I'd like to get those different perspectives on how the industry guys, how you actually conduct your risk assessment or your job safety assessment, and then from the regulators, what information are you looking for in those risk assessments that's going to satisfy you again as a regulator that they know that what they're doing?
So any of our risk assessments are done. There's a sort of a predetermined form that allows the pilot to really do a proper site survey, to look for nearby hazards, to understand weather conditions in the area, to understand the airspace that he's operating in, and based on that risk analysis, he ends up with a score that essentially says whether it's good to go or not good to go. The problem with risk assessment, the way that we see it, is that it's quite subjective, because some of the pilots, and although we found it's a very difficult thing to train, we would have a very experienced pilot that would go into a situation and his risk assessment score would come out a little bit different to a pilot that doesn't have as many hours, and we end up with a guy not sort of saying, well, I'm not going to do this task because I can't. The risk assessment is incorrect. So we, at the moment, trying very, very hard to bridge that gap between trying to teach people about the way in which they do their risk assessment and the way in which we would like to see them fly these missions, but always bearing in mind that safety first. So we've also developed a mobile application that is a risk management tool that has levels of severity that we're using to help these guys make these decisions more efficiently.
Yeah, so I think turning a risk assessment from a subjective thing into an objective thing is quite a hard thing to do. But then obviously clearly with the volume of inspections that you do to make sure that operators are continuing to update and renew their risk assessments based on the real hazards and the hazard identification that goes with it is really important. One of the things that we've tried to build into our risk assessment, which is obviously one of the tools within the flight deck software, is the ability to template stuff, but then also to do a post review to be able to come back into it to work out, where you scored a goal and where you didn't, where perhaps you didn't find, or you didn't analyse the risks sufficiently enough in the first instance. So that periodic action and review across the templates is really, really key as part of that process. But again, it's something that you need to sit people down in ground school and talk. This is all where, we need to train for technology as much as the regulatory environments with which people fly. I think that's key.
Yeah, that's good.
Regulator's point of view. Perhaps first to explain the way we've approached it in the UK, in that our guidance document doesn't give a specific type of risk assessment to do. What we've done is create a template for operators to provide the evidence that they have carried out an adequate risk assessment, that we can be satisfied that they understand the risks, predominantly that they understand the risks to who they could harm, and demonstrate that to us. So we took an objective decision not to provide a specific type of assessment. We wanted new industry operators to learn risk assessment, to understand risk, to understand how to manage and mitigate it, and to use the vast resource that is available in the commercial world to help them do that. And similarly, so that in that way they would mature and grow and be able to evolve into the different operations that they were carrying out. So we didn't set a specific. We said, just give us something that we can look at. And what we look for, back to your question, is a little bit of what I said in the presentation. What do they know about themselves and their competencies? What do they know about the machinery that they're using and the operation they wish to do? And from that, can they show that they understand the problems and the potential consequences, its severity, and show appropriate mitigations, whether that is by choosing the right tool for the job, not using one particular machine and choosing another, or putting operational restrictions or additional training or whatever they need to manage that specific threat. So we look for the holistic piece that they can do the end-to-end process.
Good.
I largely agree with what Mike has said. In addition to that, Jim, you alluded to the fact that the first unmanned flight was in 1916. We didn't get an invite to the demonstration. So our experience as a regulator is approximately 2 years old. So at the lunch presentation, it was mentioned that machine learning will be a thing of the future, or in our case, it's human learning. So we are learning all the time. And this is addressing the point that you had asked as to how do we know this fellow knows what he's talking about. Fortunately for us, the first commercial operation, and I'm acutely aware, Rob, that you guys are the first operation, but the first commercial for money operation was over a mine. And fortunately for us, the mining industry is extremely pedantic when it comes to its safety requirements and its safety systems, even more so than I would say some aviation avenues. So these operators had to not only satisfy the Civil Aviation Authority that they knew what they were doing, but they had to satisfy the clients that they knew what they were doing. And because we were involved in assessing operations in real time over the sites, we had a fair indication that they had satisfied some pretty clever guys that they knew what they were speaking about. And that's been a method of us collecting data and learning all the time. And as the environment grows and as operations grow, so will we grow as well. And then the other question is, do we know what we're talking about?
Thanks, Ian. Yeah, I think you hit the nail on the head with the mining companies. They are far more risk averse than any other organisation. Okay, we're just about come to the end of the time. So just in my wrap up, I for those of you who know anything about rugby, what I've got here, I've got 2 lions and 2 springboks being moderated by a wallaby. So, and as I said, we've had a really good panel here in terms of 2 regulators, 2 operators, which have outlined the safe use of RPAS from both a regulatory and an industry perspective. So when we look at the what, where, why and how of an RPAS operator responsibilities, I think from the regulators today, they've outlined the what and the why, and the operators have outlined the how and the where. And I think they've given us a good rounded couple of presentations and good discussions on the responsibility of an RPAS operator. I've certainly enjoyed it, and I'd like to show you to show your appreciation to the guys on the panel. Thank you. And I'll hand over to Sarah.
Thank you very much. Thank you, Jim, and thank you to our panelists for closing today with this extraordinary session. Ladies and gentlemen, thank you as well for your participation today. There is no doubt that today has been an incredibly informative series of sessions uncovering different aspects of competency-based training and related topics. With this, we wish you a great and restful evening. We look forward to seeing you back here tomorrow morning at 9 a.m. sharp for the last day of interesting and provocative discussion of this RPAS 2017 symposium. Thank you and good evening.